Okay, good morning, everybody. So I just want to make a few closing comments about working with a linked sequence of nodes when implementing a stack. And so if you've got a reference n to some node in the stack, right, you can always get to the next node, or the next node in the stack, or in the sequence in this case, is just n.next. Right? So n.next is a reference to the second node from the top. Right? And you can keep on going with this sequence of nexts. So for example, n.next.next is the bottom node in this case. If there was another node here, it would be n.next.next.next, and so on and so on and so forth. Right? And so don't remember, there is this general iteration pattern. If you want to do something with every node in the sequence, right, you start at some node. So n is typically the top node, but it doesn't have to be the top node. Right? You're going to start at some node in the sequence. Right? And then while n is not null, right, you can do something with the node. Right? At the end of the loop, you're going to advance to the next node in the sequence. Right? So n equals n.next, if you go back and look at this pattern, right, on the next iteration of the loop, right, n will be pointing at the b. Right? And of course, don't forget, you can't use n here if you're using this exact pattern here. Right? Now sometimes when you're working with these linked sequences, oh, sorry, I meant to, oh, well, no, we'll keep this. All right, now sometimes when you're working with these linked sequences, you don't want to process every node in the sequence, right? So instead, you might want to process all the nodes except the last, right? So in other words, you want n to stop at the last node, right? So remember, when you process all the nodes in the sequence, n stops after the last node, right? So if you want to process all the nodes up to but not including the last node, right? In other words, you want n to stop there, right? All you have to do is change the previous loop, right? Instead of looping while n is not null, right, you just loop while n.next is not null, right? So when the loop hits this, when n reaches this node here, n.next is now null, so it stops, right? And that leaves n referring to the last node in the sequence. And it doesn't process the last node in the sequence, right? So you have a reference to the last node now, right? And so that's how you get a reference to the last node in the sequence. Right? If you need a reference to the second last node in the sequence, right, well, just slide all this stuff up one, right? And now you're going to stop when n.next is null, right? So when n.next is null, right, n is pointing at or referring to the second last node in the sequence, right? And that might be useful for certain types of problems, right? In particular, it's useful for the next assignment, which will come out later this afternoon, right? And so the next assignment, you need there will be a question where you have to stop, where you want to stop at the second last node in the sequence, right? And of course, if you need to stop at the third last node of the sequence, you would just change the condition so that it becomes n.next.next.next is not null, and so on and so on and so forth. Right? And so there's, hopefully that clears up, or well, hopefully that makes it a little clearer how to use or how to work with a sequence of nodes. Right? You have to get used to the fact that, well, it's useful to get used to the fact that you can continually just write .next after a previous .next to move to the next node in the sequence. All right, so I think today's lecture, and probably the rest of the lectures for this week, deal with the, I guess the second last major topic in the course. The last major topic in the course really isn't that big, so this is either the last or the second last major topic in the course. And so this topic is about inheritance. All right, so inheritance is the last type of relationship that we're interested in between two classes. It is the strongest relationship that you can have between two classes. And so inheritance is a relationship where one class is derived from another class. Right, there's a quote here from the official Java tutorials. So it says, the idea of inheritance is simple but powerful. When you want to create a new class and there's already a class that includes some of the code you want, you can derive your new class from the existing class. In doing this, you can reuse the fields and methods of the existing class without having to write and debug them yourself. Right? And so that quote there strongly suggests that inheritance is mainly used for code reuse, right? When you want to create a new class, there's already one that exists, you can just derive from the existing class, right? And that gets you everything from the existing class almost for free. But the real purpose of inheritance is not strictly for code reuse. It really is a mechanism for modeling the relationship between your classes. And so we'll have more to talk, I'll speak more about that shortly. If you recall from, I think, roughly 4 or 5 weeks ago now, I introduced what's called the object model, right? And the object model has these 4 components. At the time I introduced it, I told you that hierarchy was the 4th component, and we weren't ready to talk about it at the time. Well, now you've seen hierarchy, right? And so we've seen interfaces, and today you'll see inheritance, right? And these are the mechanisms that Java uses for supporting a hierarchy of classes, right? And so this is what I mean by a hierarchy of classes, right? The classes are organized in some tree-like structure. In Java, the tree of classes has object at the top node. So object is the root node of this hierarchy, right? And that's the way it works. So in Java, every class is what's called a subclass of this thing, java.lang.object. The classes in the second level, so here, for example, you might see something like string, for example. Okay, so a subclass is a class that's derived from another class. So it's a class that's one level lower in the hierarchy. Sometimes it's one level or more lower. It depends on the terminology. Depends on who's, what the person means when they're talking about subclasses. Right? You also see the term derived class, extended class, or child class. They all mean the same thing. Right? I'm going to try to use subclass and superclass. A superclass is the class from which a subclass is derived. Right? So, the UML class diagram looks something like this when you're describing an inheritance relationship between 2 classes. Right? So X is the superclass and Y is the immediate subclass. Right? Similarly, you can call X the immediate superclass of Y. Right? Notice the direction that the arrow points in, right? It points from the subclass to the superclass. An example of this in the Java language would be the class object, right? And a direct subclass of object is the class string. And other direct subclasses of object would be every class we've created in the course so far, right? So point2 would be a direct subclass of object. Counter would be a subclass of object. And any other class that we've made on our own, I think at this point, has been a subclass of object. Okay, so a subclass can derive from a subclass, can derive from a subclass, and so on and so on and so on. So you can have these very long chains of inheritance. So starting at object, you can have a class Y, so X. So X is the subclass of object. Right? Z is the subclass of X, and A is the subclass of Z. Right? The classes below object, so A, Z, and X, we say they are descended from big O object. Right? Similarly, A and Z are descended from X, and A is descended from Z. Right? All of the classes that a class is descended from are called the ancestors. Right? So object is the ancestor of every class in Java. X is the ancestor of Z and Z is the ancestor of A. Okay, so why use inheritance? So the quote at the beginning of the lecture suggests one use of inheritance, right? So code reuse. So when you use inheritance, a subclass inherits all of the non-private members from the superclass. This does not include the constructors. So in Java, constructors are never inherited from the superclasses. Right? But everything else that's public or protected gets inherited. So that means all the fields that are public and protected get inherited by the subclasses. All the methods that are public or protected get inherited by the subclasses. When I say inherited, I mean your subclasses get those fields and those methods. Right? And you don't have to repeat those fields or methods in your subclass. Right? So if there's an existing class that provides some of the functionality you want, you can simply derive your new class from the existing class. Right? The new class gets all of the fields all of the public and protected fields and all of the public and protected methods that the superclass had. That means the subclass is immediately functional, assuming the superclass is also functional. The new class is allowed to add stuff to the new class, right? So it's able to extend the superclass, right? You can add new fields, you can add new methods, you can make the new fields private if you want to, you can make the new methods private if you want to. Right? And as we've seen already in the course, the new class is allowed to redefine or override any of the subclass methods, any of the superclass methods that it inherited. Right? And so in many of the classes that we've implemented, we've overridden equals toString and hash code. Right? So we've replaced the definition of those methods that we got from object. Okay, so inheritance is a mechanism for code reuse, but more importantly, it's meant to model the ISA relationship between two classes. Right? And so ISA means the subclass is substitutable for any of its ancestor classes. Right? And so what do I mean by that? I mean, so for example, a string is substitutable for a big O object. Right? A string object is able to do everything that a big O object can do. Right? So remember what can a big O object do? Well, big O object's got a few, or several, I guess, public methods. Right? So it's got things like equals, hash code, toString. And some other methods we didn't talk about. String also has all of those methods. Right? So any method that you can call with object, you can also call with string. Right? And that's true of the other classes we created in the course. Right? Any method that you can call on a big O object, you can also call on a point2 object, you can call it on a counter object, and so on and so on and so forth. Right? And so we say that string is substitutable for object. Java is, this class java-lang.object is unique in the Java language. Right? So it's the only class that has no superclass. Right? Every other class in Java has at least one, has one superclass. Right? And so it's the class from which all the classes are descended from. Right? It's the class that lives at the top of the hierarchy. When you create a new class and you don't explicitly state what the superclass is, then the language assumes you mean the superclass is java.lang.object. Right, so you've been using inheritance in the course all along, even though you didn't know it. So in Java, a superclass is allowed to have as many subclasses as a programmer wants to create. Right? So X in this case has 3 subclasses, but it could have 1 million. Right? The opposite's not true. So every subclass has exactly 1 superclass. Right? And so that's called single inheritance. Right? So Java is a single inheritance object-oriented programming language. Right? The only direct subclass of Y is X. Right? And that's true of Z and W as well. Right? So subclass has only 1 direct superclass. There are languages that allow a subclass to have more than 1 direct superclass. And so this picture here, this is not the Java language, right? So this is, for example, this would be a language like C++. Here Z has 2 direct superclasses, right? So it has, so Y and W are both direct superclasses of Z, right? And Y and W, their direct superclass is X, right? So remember what inheritance lets you do, right? So inheritance means the subclasses get all of the public and protected methods from the superclass. Right, so suppose X defines a public method F. Right, so what does that mean? Well, Y and W both get a method F. Right? If they choose to override F, right, so Y now has its own definition of F, and W now has its own definition of F. Right? What happens when you get to Z? Right? So does Z inherit Y's version of F, or does it get W's version of F? Right? And so this problem here is called the deadly diamond of death problem, which is a real name. So it's not something I made up. If you Google deadly diamond of death, you will get the Wikipedia page for this problem. Right? And this is a problem that any object-oriented programming language that allows multiple inheritance that has to deal with. Right? And so the Java language designers decided this is not a problem they want to deal with, right? And so they don't allow classes to inherit from more than one superclass. Okay, so what does this term ISA mean? So ISA, from a object-oriented programming point of view, means is substitutable for. And so what does that mean? It means you can always use a derived class object in place of an ancestor class object. Right? So for example, if you have a method that has a parameter of type big O object, you can call that method with any object in the Java language. Right? So here's some method. Right? Its parameter is a big O object. Right? So what types of objects can you call this method with? Well, you can certainly call it with a big O object. Right? That hopefully everybody realizes that's true. Right? So if you make a big O object O, you can call some method and pass in O. Right? But remember, in Java, inheritance means is substitutable for. So string is an object, right? So a string is substitutable for object. So I can pass S to some method, and the method works just fine. Right? Similarly, a hash set is a class. So that means T is an instance of a hash set, which also means it's an instance of a big O object. So I can pass T to some method. Right? And point 2 is also an object, right? Which means I can pass, P, not T, P to some method as well. Right? So point 2, hash set, and string are all substitutable for big O object. Okay, so what you have to remember about ISA, or inheritance, when you're working in a programming language, is that you're working with a programming language, right? And programming languages have nothing to do with the real world, right? You can do whatever you want in software, right? So ISA has everything to do with how the programmer has decided to model the classes in their inheritance hierarchy. Right? And so the classic example of this problem is a circle and ellipse. Right? So mathematically, the answer is yes, a circle is an ellipse. Right? The question is, if you need a class ellipse and a class circle, right, can you implement circle by inheriting from ellipse or by extending the ellipse class? Right? So that's the big question. Right? And unfortunately for you guys, the answer is maybe. It's not yes or no. Right? So mathematically, a circle is a kind of ellipse. Right? Programmatically, if an ellipse object can do something that a circle object cannot do, then you can't implement circle by having it inherit from ellipse. Right? So remember, circle has to be able to do everything that an ellipse can do. Right? It has to be substitutable for ellipse. If that's not the case, you shouldn't be using inheritance. Right? So remember, ISA means you can substitute a derived class instance for one of its ancestor instances. Right? So any method that requires a circle, I should be able to pass an ellipse, and the method should work the way it says it's supposed to work. Right? If that's not the case, then we have a problem. Right? You cannot safely substitute circles for ellipses, and that breaks the idea that inheritance models the ISA relationship. Right? So you can easily do this with circle and ellipse. Right? So imagine you have your class ellipse. Right? If you don't know what an ellipse is, it's just an oval. Right? So you can think of it as a circle that's been stretched in one direction. If in the class ellipse, you have a method that lets you change the size of the ellipse. So you can change its width and you can change its height. Right, to some non-negative width and height. Right? For an ellipse, that's fine. Right? You can independently change the size, the size of the height and the width of the ellipse. Right? And that's a perfectly normal operation that you would do with an ellipse. Right? Makes sense mathematically, makes sense if you're thinking of ellipses as ovals and you're trying to make a drawing program. Right? So this method is perfectly legitimate, exists in ellipse. Right? What's the problem now with circle, right? So if you say that circle is an ellipse, that means circle gets a set size method, right? Does it make sense to change the width and the height of a circle independently? The answer is no, right? A circle is a shape whose width and height are equal, right? And so now you've run into the problem where set size for circle doesn't do what set size for ellipse says it does. Right? Set size for ellipse says the width and height both change. Right? So if you do this for a circle, that means your circle is no longer a circle, which is kind of busted. Right? And that means that you probably shouldn't be implementing circle as a subclass of ellipse. Right? Okay, so the question, so what happens if there is no set size method? Right? So in other words, your class ellipse doesn't let you change the size of the ellipse. Right? It might return the width and height of the ellipse, but it doesn't let you change the size of the ellipse. Right? And so the answer to the question, can you implement circle by extending ellipse? The answer is still maybe. Right? You still have to check. Right? Can a circle do everything that ellipse can do? Right? So in other words, if you look at all the ellipse methods and you say, yes, those all make sense for a circle, then you can implement circle by extending ellipse. Right? If any one of the methods does not make sense for circle, then you should not be using inheritance to implement circle. Okay, so we've been talking about stacks, right? And you've probably seen, we've seen 3 implementations of it, and you're probably sick of it by this point in time, right? But you can implement it in yet another way, right? You can use inheritance to implement a stack, right? So why do I say that you can use inheritance to implement a stack, right? Because a stack looks an awful lot like a list, right? If you push an element onto the top of a stack, that's just like adding it to the end of the list, right? And popping an element from the top of the stack is just like removing the element from the end of the list. And we know how to add and remove from the end of a list, right? So you can implement stack by inheriting from something like ArrayList, right? So if you want a stack of integers, one way to implement a stack of integers is to inherit from ArrayList, right? And it's dead easy to do, right? That's it, right? So if you want to implement, so in inheritance, right, when I create a class, right, you state which class you're inheriting from, right? So you use the keyword extends, right? And then you state the class which you are extending, right? Or you state the direct superclass. So I want bad stack to descend from, or inherit from, or be the subclass of ArrayList integer. Right? What does this mean? Right? So it means every stack, or every bad stack, has all of the methods that ArrayList has. Right? So to implement push, right, I just need to add the element to the end of the list. Right? Bad stack is a list. Right? So that means that I can call add using this. Or you can just write add. You don't even have to write this. Right? Every bad stack has an add method, so I can call the add method. Right? And I can add the value that was pushed onto the stack. Right? Similarly, every stack has a remove method, right? Because remove came from ArrayList. So I can use this to call the remove method and remove the last element of the stack. Oh, we also have a size method, right? So bad stack gets size for free as well. It also gets is empty. Unfortunately, it gets every other method as well, which we'll see as a problem in a second. But that's it, you're done. So there's your stack implementation in 1, 2, 3, 4, 5 or 6 lines of code, right? And it works, right? So you can make a stack, push a bunch of stuff onto the stack. You can even print out the stack for free because ArrayList has a toString method. So that means bad stack has a toString method. And so that means println can call toString on T when you call println. Right? If you pop the elements off the stack, it works just the way you would expect it to. Right? So there's our stack 0, 1, 2. So 2's at the top, 1's in the middle, 0's at the bottom. Right? When you pop the elements, you get 2, 1, and 0. If at the end of the main method here, you asked what is the size of the stack, you would get 0. Right? The class is perfectly functional the way it's written. Okay, so what's the problem? So remember what inheritance means. If bad stack inherits from ArrayList, you are saying a stack is a list. And that's not true. That's not what a stack is supposed to be. Right? If you're using a stack, the reason you're using the stack is because you only want stuff to happen at the top of the stack. Right? By saying that bad stack is a list, you can now do stuff like go into the middle of the stack and look at the element that's there. Right? You can also go into the middle of the stack and change the elements that's there. you can remove any element from the stack, right? Rather than just removing the top element, right? Now the last one's actually handy. You can actually iterate over the elements of the stack, and you might actually want to do that. So it might make sense to have an iterator, to have stack implement iterable, right? You get that for free if you inherit from ArrayList, right? But you also get all of the consequences as well, right? Your stack is no longer, strictly speaking, a stack, right? It's also a list, right? And now you can do stuff with the stack that you are not expecting. Users of your stack can now do things with the stack that they should not be able to do. Right? So for example, can I get the middle element out of the stack? Yes, you can. Right? Bad stack is a list, so that means it has a get method, so I can get the middle element in this case. Right? I can set the middle element, right, which you're not supposed to be able to do in a stack. Right? And because that stack is a list, these actually work, right? And so you can see that I can get the middle element from the stack, and I can change the middle element from 200 to minus 1,000 in the stack. Right? Your stack is no longer a stack, right? It's something else. Okay. So that's an example of incorrect, a strictly speaking incorrect usage of inheritance. It's convenient, right? We could implement the stack in a handful of lines of code, right? But it is a poor example of using inheritance, right? You should only use inheritance when this is a relationship actually exists, right? Stack is not a list. You should not be using inheritance, right? Now, if this all seems a little bit confusing to you, you shouldn't feel bad. Right? Experts, and by experts I mean the people who created the Java language, get this wrong. Right? If you go looking in the stack, well here, let's go do this. Sorry, let me do this. So if you Google Java stack, you will come across a stack class or the documentation for a stack class in the Java language. Right? If you look at how they implemented stack, so this stuff here shows you the inheritance hierarchy. Right? So down here we have stack, right? And this says that stack inherits from this thing called vector. Right? And if you go and look at vector, notice that vector you can see inherits from abstract list. So you can guess that a vector is a list. Right? If you go and look at vector, vector is the old version of ArrayList, right? And so the Java language designers did exactly what I told you not to do. They made stack a subclass of a list, right? And the consequences of that is that with a Java stack, I'm not even sure that, yes, there's pop, there's push, but there's all the other methods you can do with a stack, right? You can get an element out of the stack. You can set any element you want in the stack, right? And you can do all sorts of other stuff you can do with a stack that you're not supposed to be able to do, right? You can remove stuff from a stack and so on and so on and so forth. Right? So even expert programmers get this wrong. In the 90s, I guess, and in the 2000s, when object-oriented programming started to become very popular, you would come across code that had all sorts of incorrect inheritance. Right? And the general advice given today is that you should generally avoid inheritance when you can. Right? So, how do you avoid inheritance? Well, one solution is to use composition instead. Right? And so the very first implementation I showed you of a stack used composition. Right? Rather than saying stack is a list, right? Remember what composition means. Composition means stack has a list. Well, that's association. Stack owns a list, right? So that's composition. Right? And so we've already done that. That's the correct way to implement a stack using a list. Right? The implementation is not much harder than with inheritance. Okay. So let's actually use inheritance for a. Let's try to correctly use inheritance for some reason. So this is, the reason the counter class is used in this course is because it's basically the simplest class that I can come up with where inheritance actually makes sense, or arguably makes sense. Right? So it's a very easy class to implement. Hopefully it's easy to understand. right? And now hopefully it's easy to show you how to extend this class to change the way that the counter behaves. Right, so remember how our current counter behaves. It's a thing, it's an object that knows how to count in increments of 1 starting at 0, right? Or starting at some non-negative number, right? If you go past the largest value that the counter can count up to, it wraps around back to 0. Right. Okay, so what happens if you don't want to wrap around back to 0? What happens if you want to do something else? Right. So this wrapping around to 0 is problematic. So it's easy to find a bunch of video games where the score is kept as an integer value. And when you hit the maximum value that the integer can represent on that video, in that video game, what happens is, what usually happens is that the score wraps around back to 0. Right? Similarly, you might have, so in the game Slay the Spire, you can apply poison to the enemy. And there's a maximum value that, there's a maximum amount of poison that you can apply to the enemy. Right? If you apply too much, weird things happen. Right? And so you might want to change the way that this counter behaves when it hits the maximum value. Right? So remember how the counter class works? It's very simple, right? It has a private int value to keep the count. Right? And it has an advanced method that when you hit integer max value, the value wraps around back to 0. Right? So if you want to change the way that the counter behaves when it hits maximum value, you can extend the counter class, right? So you can use inheritance and create a new kind of counter, right? When you create the new counter, you replace the way that advanced behaves, right? So you override the behavior at advanced to provide whatever behavior you want when you hit max value, right? Okay, so we have a bit of a problem here, right? Our field in counter is private. When you use inheritance, the subclass does not inherit the private fields. Right? Furthermore, the field is private, so there's no way for the subclass to access the field value. Right? So if I make some class, so my counter extends counter, right? There's no way that I can write this dot value inside my counter. Right? The field is private, it's not inherited, and I can't see it. Right? Even though I'm a subclass of counter, I cannot see the private fields of counter. And so if I can't see value, there's no way for me to implement advance. So that's a problem. Right. So this turns out to be a very common problem when you're trying to use inheritance. Right? If you try to use inheritance and you're trying to extend a class that was never originally designed for inheritance, you're probably going to run into this problem. Right? You probably will not have access to the fields of the class that you're trying to extend. Fortunately, we're the ones that created the counter class, so we can go ahead and change the way that counter works. We can change the implementation of counter. Right? So I really need to make that field value accessible to subclasses. Right? And that's what the protected access modifier is for. Right? You use the protected access modifier when you are creating a class where you are intending people to extend it. Right? So in counter, if I want people to extend the counter class, I should make the value field protected. Right. So change number 1, change value from protected to private. This is just another constructor. So this is a constructor that lets you set the starting value of the counter. Right. There's also something else we need to change. So I need to change this contract for advance. So where's advance? Here's it. So the contract for advance, or the specification for advance, or the documentation for advance, right, says that whenever you advance a counter, it wraps around back to 0 if you hit max value. Right? I want the subclasses to behave differently than this. Right? So remember what inheritance means. Inheritance means is substitutable for. Right? So if I extend counter, right, then any subclass of counter, its advance method needs to behave this way. Right? In other words, when you hit max value, it also has to wrap around back to 0. Which defeats the purpose of extending counter. Right? I want to extend counter so that I can change the way that advance behaves. Right? So not only do I have to change the access of the field in the class, right, I also need to perhaps look at how my methods are documented. So what are the specifications for my methods? And I may have to change the specifications of the methods so that subclasses can reasonably can replace the definition of the method and still satisfy the description of the superclass method. here, right? So in this case, it's easy, right? So in the counter class, advance still causes the counter to wrap around to 0, right? But now it's indicating that subclasses can override this behavior, right? And so this indicates to people who are using our counter class that advance might not always wrap around back to 0 when you hit the maximum value, right? If some other counter is being used, right, it's probably the case that we're not going back to 0, but something else is going to happen instead. Right, so why are we modifying? Again, so why are we modifying the specification of advance? Because subclasses are supposed to be substitutable for the superclass. If I don't modify the specification of the method, right, every counter is going to behave the same when you call advance. Right. Okay, so now we're ready to actually implement a new type of counter. Right. So for example, a reasonable thing to do when you hit max value is to stop counting. Right? So in other words, when you hit integer max value, you stop at integer max value, and every time you call advance, you don't go past max value. Right? So how do you implement this thing? It's very easy to implement. Oops, sorry. Okay, step 1, you create your class. Right? So public class, you give it a name. So I'm calling it stopping counter. Right? We're using inheritance. So you say what class you are inheriting from. So we're going to extend the counter class. Right. When you create your class, or when you create any class in Java, you're always asking yourself, what information do I need to represent the counter, to represent this class? Right. So here, I do not need to add any extra fields. Right. Remember, you're going to inherit the value field from counter. Right. So your stopping counter already has a field to store the value of the counter. There's no reason to add another field, right? So no fields. If there is a reason to add a field, you can go ahead and add it here, right? But in this case, there's no need for another field to keep the value. Furthermore, you don't want to repeat the field that you got from counter, right? So in other words, you don't want to write in here private or protected int value, right? What the problem that introduces is that your stopping counter now has 2 fields called value, right? One of the fields belongs to the stopping counter. The other value field belongs to the counterpart of stopping counter. And I'll have more to say about that later on. Right? So whatever you do, do not repeat the fields that you inherit from counter, right, from the superclass. So stopping counter has no fields of its own. The current value of the counter is stored in a field that belongs to the superclass. Right? There is no need, and it is incorrect for stopping counter to add its own field to store the value. Right? If you want to and you need to, you can add extra fields. Right? The fields that you add to the subclass are not visible to the superclass. Right? And so the inheritance relationship in Java is one way. Right? The subclass knows a lot about the superclass. Right? But the superclass knows nothing about its subclasses. Right? If you think about it for a minute, that has to be true. Right? The Java language designers made this class called Big O Object. Right? And they have no idea what other classes everybody else in the world is going to make. Right? So there's no way for object to know about any other class that someone else creates. Right? So superclasses know nothing about their subclasses. Subclasses know everything that's not private about their superclasses. Okay, so when you implement a subclass, you do not inherit the constructors from the superclass. Right? So you have to add your own constructors. So I would like to add a no argument constructor to stopping counter that sets the value of the counter to 0. Right? And so the question is what the heck goes here? And the answer is there's a lot of things that you can put here. Right? So remember what a constructor is supposed to do. Right? It doesn't matter if it's a constructor in a subclass or not. Right? The purpose of every constructor is to initialize the fields of an object. Right? So here in inheritance, the field does not belong to the subclass, right? It belongs to the superclass. So the value field, right? Remember, it lives in the superclass counter. And so the question is how do I get to that field here? Right? And so because we made the field protected, the subclass can actually see that field. So one way to implement this is to write this value equals 0, right? And that would be fine. Right? There is another way, and perhaps there's another way that you should implement this method, constructor. Right? So if I want to set a field that belongs in the superclass, right, there's a mechanism already for me to do that. Right? The superclass has a constructor, and that's the job of a constructor. Right? The job of the constructor is to initialize the fields of an object. So what I really want to do here is I want to call the superclass constructor. Right? I want to call the counter constructor to set the value of the counter to 0. Right? And this works even if the superclass field is private, right? As long as the constructor is not private. So how do you call the superclass constructor from the subclass constructor? Use the keyword super. Right? And then you put in the round brackets. And then if the constructor has any parameters, you pass in the arguments to the constructor. Here I want to call the no argument counter constructor. So it's just super round bracket, right? That calls the superclass constructor, which sets the counter's value to 0. Right? All right, so there are some rules that you need to know when you implement a constructor of a subclass. These rules are particular to, the way that you implement this is particular to Java, but most object-oriented programming languages have a similar set of rules. Okay, so rule number 1. Oh wait, so quickly check. Okay, rule number 1, when you implement a constructor in a subclass, the first line in the body of every constructor must be a call to another constructor. Right? We haven't done that in the course yet so far. But it turns out this is the rule in Java. Right? So on the first line of your constructor, you should be calling another constructor. Right? So on the first line of the stopping counter constructor, I am calling the superclass constructor. That is exactly what I'm supposed to be doing. Right? Now, we haven't done this yet in the course. Right? So when we made point 2 or counter, if you look at their constructors, they don't call another constructor. So what's happening there is that the compiler is inserting a call to the superclass no argument constructor for you. Right? So in other words, if you don't write that, the compiler is writing that for you. Right? So if you look at our point 2 class, right, in the point 2 no argument constructor, it's just this x equals 0 and this y equals 0. But before those 2 lines of code, the compiler has inserted the call to the superclass constructor. Right? The superclass constructor for point 2 is the constructor for big O object. Right? So it's initializing the big O object part of every point. Right? Here, we're initializing the counter part of every stopping counter. Okay, so if you forget to write the call to the superclass constructor, right, the compiler tries to insert the call to the no argument constructor for you. If that constructor does not exist or is private, then you get an error, right? So your new class will not compile. All right, rule number 2. If you're going to call a constructor from another class, if you're going to call a constructor from within a constructor, the only place you can do it is on the first line of the constructor. Right, so here we have a call to the superclass constructor. This is the only place you can do this in this constructor. Right? You can't do any validation and then call the superclass constructor. Right? You can't have some code and then call the superclass constructor. You must call it here. Right? So 1, the first line of the body of every constructor should be a call to another constructor, and 2, that's the only place you can put it. Right? And finally 3, at some point during the initialization of a subclass, a superclass constructor has to be called. Right? You don't have to call the no argument superclass constructor, right? You can call any superclass constructor. Right? All right, so keep those rules in mind while we add a second constructor to our class. So I'm going to add a second constructor that initializes our stopping counter to some non-negative, so it sets its starting value to some non-negative value, right? So not 0. And not negative. Right, so I'd like to set the counter to some specified value. Right, and furthermore, I have to make sure that the value is not negative. Right, so what goes here? Rule number 1, there has to be a call to a superclass constructor. There has to be a call to another constructor, right? So that has to go there. So I don't remember if I showed you what constructor chaining is. But constructor chaining is when you call a constructor, you call a different constructor from within a constructor in the same class. Right? So the first line of a constructor, you're supposed to call another constructor. It doesn't have to be the superclass constructor. Right? All that's required is rule number 3. At some point, the superclass constructor has to be called. Right? So here, right, instead of implementing the no argument constructor by writing super round bracket, right, I can instead write this 0. Right? When you use this instead of super, you're going to call another stopping class constructor, stopping counter constructor. So this calls this constructor here, which is fine. Right? The first line of the constructor body should be a call to another constructor. Okay, so we'll call this one down here. Right? Now this one, the first line of its body, calls the superclass constructor, which sets the value to that value there. And so that satisfies now rule number 3. Well, it satisfies rule 1 and 3. 1, 2, and 3, I guess. Right? So this causes the superclass constructor to be called. Right? So if we use this constructor here, right, that calls this constructor here, which calls the superclass constructor. So that satisfies all 3 requirements. If I use this constructor here, that also satisfies all three requirements. Right? First line is a call to a constructor, which satisfies requirements 1 and 2, right? And we call the superclass constructor, which satisfies rule number 3. Right? There are many ways to implement these constructors. Right? This is not the only way. Right? You could write this value equals 0 and leave it at that. Here you can write this value equals value and leave it at that. Right? If you do that, the compiler inserts the call to the superclass constructor here and here for you, right? And you still end up with the desired behavior. And similarly, there's other ways to write the chaining to produce the correct effect. Right? But this is just an example of one way to write this. All right, now you might wonder why the heck are there all these rules, right? And so I guess I should stop here because I'm not going to get through this. Right? And so there is a reason why these rules are in the language, right? And that has to do with what exactly is a subclass. Right? And so in the next lecture, I'll explain exactly why those rules are required, right? And what's really happening when you're calling all of these constructors. Right? So assignment 5 will come out later this afternoon. It deals with a bunch of things, right? Because it's the last assignment in the course. So the first part of the assignment deals with working with interfaces and working with a linked sequence of nodes. The second part of the assignment deals with inheritance. So when it comes out, you either want to read ahead to do the inheritance part, or you can just wait a few days, and then you'll know enough from the lectures to be able to complete the second part of the assignment.